Imagine our universe like a grand shadow play, a cosmic theater where shadows dance and tell stories. These shadows, cast by unseen objects, captivate our attention and spark our curiosity. The shadows dance and twirl, captivating our attention. They move with a grace that seems almost magical, drawing us into their mysterious world. In our everyday experience, we see three dimensions: length, width, and height. These dimensions define the space we live in, the objects we interact with, and the world we perceive. But what if these shadows are merely projections of a higher unseen reality? What if there is more to our universe than meets the eye? This is the essence of the 4D shadow hypothesis. It suggests that our three-dimensional world is just a shadow, a projection of a more complex four-dimensional reality. It proposes that our three-dimensional universe is a projection of a more fundamental four-dimensional reality. This fourth dimension is not just another spatial dimension like length, width, or height. This fourth dimension is not spatial like the others. It's something else, something more profound, something that we can only begin to imagine. It's something else, something more profound. Think of it as a hidden layer of reality, a dimension that shapes and influences our world in ways we cannot directly perceive. Think of a flat, two-dimensional world. Imagine its inhabitants living their lives on a flat plane, completely unaware of the third dimension. Imagine its inhabitants unaware of the third dimension. They would see only length and width, but no height. Their world would be flat, and their understanding of reality limited to two dimensions. Now picture a three-dimensional sphere passing through their world. As the sphere intersects their plane, they would see a series of shapes that change over time. They wouldn't see a sphere, would they? They would only see a series of changing circles, appearing as if from nowhere, growing, then shrinking, and finally disappearing. To them, it would be a mysterious and inexplicable phenomenon. They would only see a series of changing circles, appearing as if from nowhere, growing, then shrinking, and finally disappearing. This is how a higher dimensional object would appear to beings in a lower dimensional world. The 4D shadow hypothesis suggests that we too might be witnessing the projections of higher dimensional objects and events. Our three-dimensional experiences could be shadows of a grander, more complex reality. Our universe, with all its wonders, could be just a glimpse, a shadow play of a grander four-dimensional reality. This idea challenges us to expand our understanding of the cosmos and consider the possibility that there is much more to discover beyond the dimensions we know. Black holes, those enigmatic cosmic monsters, have long fascinated scientists and astronomers alike. These mysterious entities, formed from the remnants of massive stars, possess gravitational pulls so strong that nothing, not even light, can escape their grasp. They might hold the key to unlocking the secrets of the 4D shadow hypothesis, a theory that suggests our three-dimensional universe is a mere shadow of a higher four-dimensional reality. These gravitational behemoths, where even light cannot escape, are not just cosmic vacuum cleaners. They could be portals to this higher dimension, acting as gateways that connect our universe to a more complex, multi-dimensional space. Imagine, if you will, that information is encoded onto the surface of a black hole, much like data on a holographic plate. This concept, known as the holographic principle, suggests that all the information contained within a volume of space can be represented as a theory on the boundary of that space. As a black hole grows, its surface area increases, allowing it to store more and more information. This means that black holes could potentially hold vast amounts of data, far beyond what we can currently comprehend. This information, however, wouldn't be lost within the black hole's singularity, the point at which density becomes infinite. Instead, it would be preserved as part of its four-dimensional structure, maintaining the integrity of the data in a way that defies our conventional understanding of physics. From our three-dimensional perspective, it might seem like information disappears forever into a black hole. But in the context of the 4D shadow hypothesis, it's merely being transferred to a higher dimension, archived within the fabric of the four-dimensional universe. This means that black holes are not just destructive forces but also preservers of cosmic information. They act as cosmic librarians, safeguarding the universe's information within their enigmatic depths. The idea that black holes could serve as archives for the universe's information is a profound one. It challenges our understanding of reality and suggests that there is much more to learn about the nature of the cosmos. In the grand tapestry of the universe, black holes may play a crucial role in maintaining the balance of information. They ensure that nothing is truly lost, but rather transformed and preserved in a way that we are only beginning to understand. Black holes then become not cosmic destroyers but cosmic librarians, safeguarding the universe's information within their enigmatic depths. They are the keepers of the secrets of the cosmos, holding the key to understanding the true nature of our reality. We often think of space as empty, a vast nothingness between stars and galaxies. But what if space itself is a medium for transmitting information, much like a superconductor carries electricity without resistance? Imagine information flowing through the very fabric of space-time, connecting every point in the universe. This flow of information could be the foundation of the four-dimensional reality we're projecting from, the unseen network that underpins our observable universe. Just as a superconductor allows electrons to flow freely without losing energy, space might allow information to travel vast distances instantaneously, connecting seemingly disparate parts of the universe in ways we're only beginning to grasp. This interconnectedness could explain the spooky action at a distance observed in quantum entanglement, where particles appear to communicate instantly across vast distances. Section 4. Fleeting Thoughts in the Cosmic Machine, Consciousness and the Four-Dimensional Structure. Where does consciousness fit into this grand cosmic picture? The four-dimensional shadow hypothesis suggests that our individual consciousnesses might be temporary manifestations of the underlying four-dimensional structure. Think of consciousness as a kind of RAM, the working memory of a computer. It's fleeting, constantly being refreshed and updated. In the context of the four-dimensional shadow hypothesis, our consciousness could be a temporary projection of our four-dimensional selves onto the three-dimensional canvas of the universe. Our brains then become receivers, attuned to the flow of information from the four-dimensional realm. They process this information, creating our subjective experiences, memories, and sense of self. When we die, this connection is severed, our consciousness dissolving back into the four-dimensional substrate from which it arose. Section 5. Gravity's grip compressing knowledge into the fabric of existence. Gravity, the force that binds stars, planets, and galaxies, might play a more profound role in the four-dimensional shadow hypothesis. This hypothesis suggests that our three-dimensional universe is a projection of a four-dimensional reality. In this context, gravity could be the key to understanding how information is compressed and stored in the fabric of space-time. It could be the force responsible for compressing information into the fabric of space-time, weaving knowledge into the very essence of existence. Just as gravity shapes the physical structure of the universe, it might also shape the informational structure, creating a cosmic tapestry where every thread is a piece of knowledge. Imagine gravity as a cosmic sculptor, shaping not just the distribution of matter, but the distribution of information as well. This sculpting process could be akin to how a river carves its path through the landscape, leaving behind a record of its journey. In the same way, gravity could be carving out the informational landscape of the universe. Massive objects, like black holes with their immense gravitational pull, would then become repositories of vast amounts of information, compressed and stored within their four-dimensional structures. These cosmic giants could hold the secrets of the universe, acting as libraries of knowledge, where each bit of information is meticulously cataloged and preserved. This perspective offers a tantalizing link between physics and information theory. It suggests that the universe is not just a physical entity but also an informational one, where the laws of physics are the rules governing the processing and storage of information. This idea opens up new avenues for understanding the nature of reality and our place within it. It suggests that the laws of physics as we understand them might be emergent properties of this underlying information processing system. In other words, the fundamental forces and particles that we observe could be the result of deeper informational processes at work. This could revolutionize our understanding of the universe, leading to new theories and discoveries. Gravity then becomes not just a force of attraction, but a force of knowledge, shaping the universe and everything in it. It is the thread that weaves together the physical and informational aspects of reality, creating a unified tapestry that tells the story of existence. As we continue to explore this idea, we may uncover new insights into the nature of gravity and its role in the cosmos, deepening our understanding of the universe and our place within it.